this is kind of special weekly meeting because it will be more like an onboarding session rather than a standard weekly meeting where we are going to talk about bugs and feature requests and things like this. But today it's a bit special, so it's more about helping newcomers to understand how to use the stack as it is today, how to deploy it, and potentially how to add or develop new features into Silva. Do you see my screen?
Yeah.
Okay. So I will start with an introduction about this specific working group. We have kind of
yeah, Joe, I'm going to put your microphone on mute.
Okay. Yes, a quick introduction about the working group number 1 in Silva, dedicated to development. So the goal of this working group is really to define what components we are putting in the stack, how to deploy the stack, how to manage the life cycle of the stack. The goal is really to consume as much as possible components that are coming from upstream projects, from the CNCF community especially. But we will probably have to develop some components that are missing in order to have a Silva stack ready for production and ready for being deployed in the context that we see at each operator. So again, developing the stack and managing the releases of the Silva stack is really the goal of this working group. The requirements that we are taking into account into this working group are coming from various side projects. The other projects coming from other working group, of course. I think especially about the validation center, which is managing the validation of CNF deployment on top of Silva. This will be a way for the Silva development working group to get some requirements from the CNF vendor to better understand what is missing from a CNF point of view, and potentially discuss about how the CNF is deployed on top of Silva and what could be improved in Silva or in the CNF to better work together. So the validation center working group, but also the energy working group, and potentially other working group. The security working group is also very important for Silva. So the working group, but the requirements are coming also from telco infra related projects, such as Open RAN specific projects, which is defining an infrastructure to support deployment of RAN CNFs. This has to be taken into account by Silva because Silva is targeting some RAN infrastructure deployments. I'm thinking about the Anuket project also, which is defining what telco Kubernetes infra should look like, how it should look like, and we are kind of an implementation of what Anuket could define. And I'm also thinking about the Nephew initiative, which is kind of standardizing the way CNF could be deployed, managed on top of telco infra, but there is also a scope of Nephew, which is about defining what is this Kubernetes telco infra, So we need to interact with the Nifio project to potentially use Silva in the Nifio context also. So two useful links here, which are the main GitLab organization or projects that are maintained by the working group number 1, the development working group. So there is the Silva core project, which is really about defining every component that are part of Silva, but also proposing some scripts, some tools to deploy Silva and to manage Silva components. And a GitLab sub-organization, which is Silva Element, which are about some end charts or some container images or any kind of specific Silva projects that are consumed by the Silva core project to deploy them. So those are the two main GitLab project and organization that the developers are going to contribute to for developing the Silva stack. Okay, just one focus about the main Silva technical elements that we rely on today. First of all, to deploy the Kubernetes clusters, we are heavily relying on cluster API and some cluster API providers, kubeadm provider for the Bootstrap provider, but also OpenStack infra provider, vSphere infra provider, and MetalCube infra provider for deploying the stack on bare metal. We are working also on a specific RK2 Bootstrap provider, because RK2 is really interesting to Silva because it comes with some security hardening, and security is really a hot topic into Silva. So we are going to allow deployment of RK2 clusters into Silva with CIS profiling activated into Kubernetes RK2 clusters. But we also propose some way to harden the OSs that the cluster are going to rely on and to be deployed on top of. And one also other essential element to Silva is the GitOps way to manage the lifecycle of each Silva element. We are going to rely on Flux for the moment for managing the GitOps part of Silva, and the final goal is really to adopt the GitOps approach to manage any operations that we are going to use to upgrade, deploy, delete any components deployed on top of Silva, or even any Silva stack.
Sorry, a quick question.
Yes,
sorry, I had a quick question on the previous slide.
Yes.
So I see that RKE2 is being used in the current release, but is the idea to use a different open source project or operating systems or stacks in the next releases, or is the plan to stick with RKE2?
In Silva, we are maintaining two ways to deploy a Kubernetes cluster. We want to be able to deploy RK2 clusters, of course, but also kubeadm clusters, okay, by relying on the kubeadm cluster API Bootstrap provider.
Okay, so means kubeadm plus cluster API is also a part of this release, or will that come in the future releases?
No, it will be part of this release too.
Okay, that's good to know. Thank you.
Okay. And concerning the OS, we'll come into it in the next slide. So speaking specifically about the OS, we are going to rely on Ubuntu 22.04 hardened with a CIS script run on it to harden the OS part. But yes, this is really about what we are going to test in a specific CI. The way Silva is deployed and is the way we are working today is really about giving the possibility to any operator or any editor to manage any component Silva is going to rely on or is going to deploy. So that any component which is part of Silva today, which is tested in CI, can be switched to easily switched to another component that an operator prefer to rely on. Okay. So this is really about what Silva Core is doing, and Thomas and François will speak more about it. But Silva Core is really meant to be a tool that give flexibility for deploying any components, added components, or additional components, or different version of any Silva components into the Silva stack. So what we are targeting for the V0.1 version of Silva is this picture. So a bunch of tools to deploy easily Silva based on EV usage of GitOps Flux objects. We are using Vault. It's deployed today. We are going to use Cluster API, as I mentioned. We are working on the adoption of Arbor automatically deployed on top of the management clusters. We are using Rancher as a proxy and also as a portal for managing, for at least supervising the different clusters. I'd like to target RK2 version 1.25 and kubeadm version 1.25. For the moment, what you will see in Silva is a usage of Kubernetes version 1.24, but we plan to upgrade before releasing the version. Same for the OS. For the moment, we are relying on Ubuntu 20.04, but the target for this release would be to use Ubuntu 22.04. We want to be able to deploy some clusters on top of different infrastructure. What we are going to test in the CI that is going to be publicly available in Silva is some deployment of RK2 and even of kubeadm clusters on top of an OpenStack infrastructure. But I know that at Telecom Italia, they are heavily testing some deployment of clusters on top of VMware infrastructure and bare metal infrastructure. So this is the reason why you can see a lot of components that allows you to deploy Silva on top of such infrastructure today. But I don't know, maybe Federico or Alessandro, you can speak about the maturity of what you are doing about bare metal deployment or vSphere deployment. I'm not sure that we will be able to have CI publicly available for testing such infrastructure and deployment of Silva on top of those infrastructures.
Hello, Mathieu. Thanks. The problem of CI testing is essentially the ability to access our lab infrastructure. It's not easy. There are some security concerns that we have to address. So not sure we will be able to handle this smoothly. But what we are doing today is to mirror the content of the repository in our internal repository in the lab, so that we have from there we have access to the lab infrastructure, and we are sure to be in line with what is the current release in the official Silva repository.
But what we can say is that any newcomers interested in deploying Silva on top of bare metal or VMware can already rely on what we are producing in Silva, because
yes,
you keep maintaining it.
Yes, correct. What is available in the official repo is can be absolutely used by anyone.
Thank you, Alessandro. One of the goals of this V0.1 version that we want to release before the end of March is to deliver something to the validation center for it to start testing some the validation of the first CNF. So it comes with some requirements. This CNF needs some specific CNI plugin, especially deployed on top of the workload clusters. So those are Multius, of course, and IPVLAN and whereabout CNI plugin. So it's under review, the deployment of those specific CNI plugins. It may have merged, I'm not sure about it, but it will be available in the V0.1 release for sure. And we are also deploying some monitoring stack for monitoring every Kubernetes clusters based on Grafana, and Prometheus. I'm seeing it as a work in progress, because we are switching from a usage of Fleet for deploying this monitoring stack to more standard usage of Flux, as we use Flux for every other components in the stack as of today. So just one other point, you will see that you will be able also to deploy the stack on top of Docker. This is really about being able to easily deploy the Silva stack on the developer laptop, for instance, or even in a small CI. François and Thomas will probably speak about it, but this is not the target of this Silva is not to support deployment of cluster on top of kind or Docker containers, Docker clusters. So what we are working on is setting up a specific CI, as I said, to deploy every Silva component targeted for the V0.1 on top of an OpenStack infrastructure. So this is a work in progress and will be publicly available soon. Any question about this specific target and the components that we have adopted so far? Okay, so this is really an onboarding session. So I will let the floor to Thomas. It's okay for you, or François, I don't know. You're in mute, Thomas. So, okay. It was... Yeah, the goal here is to show you how we can deploy the stack as it is today, based on the scripts that we are providing, and to explain you how to adapt the parameters of the Silva stack to the context of your enterprise. Thomas, do you want to take the floor? Or still have mic issue? Still in mute.
Can you hear me?
Ah, it's better.
Okay, sorry. Yes, so so it's meant to be as interactive as possible, even though you are many on the bridge. Don't hesitate to ask questions. So what we had in mind for this onboarding session was to have a real deployment going on, the kind of deployment that we use for development. We had the choice between using the CAPD provider for cluster API, which relies on a local Docker, what Mathieu was mentioning as an environment that can be suitable for a small development environment, or what we use in CI today. Since we know that we have some subtle issues actually not related to Silva, but related to upstream CAPD and containerd that aren't solved, we prefer to do a deployment on OpenStack using the Capo provider. So what we propose to do is to just show you how it is started, what we do to actually run it without too much explanations, and go through some slideware animation to do a bit more of explanation before going back to the platform and explain how it's configured and how we can interact with it. Because it actually takes, of course, a few minutes to start anyway, so we should have some time in between to show a few slides. Let me share my screen. Can you see my screen?
Yes, it's okay.
Yes.
Yep.
Thanks.
Yeah.
So what you see is actually a checkout of Silva Core, which is our main repository. What I will do is just create a local kind cluster. Sorry, all stuff in my tree. So I will create a local kind cluster. This is what we call the bootstrap environment. I will just explain afterwards with a little bit of detail what it is. So kind is pretty quick to start. Let me start the animation at the same time. It's a bit related. Can you also see the animation?
That's what it.
So one major goal for Silva is to build something that will handle the full life cycle of a CAS platform, and that includes the life cycle of the management cluster. And what I will show you here explains how we start things, because we cannot manually create the management cluster without introducing questions that are very hard to answer in terms of how this management cluster is upgraded, and also how we benefit from the advantages of declarative approaches to manage the management cluster itself. So what we do in Silva is that we first create what we call a bootstrap environment, which is very short-lived. So in the case here today, the bootstrap environment is just actually my laptop, but it could also be a throwaway VM. It could be actually mostly anything. Some people in the team use their Windows laptop with WSL2. So there are different things that we can use, and we are not heavily coupled to in terms of the choice of OS here. It just needs to be able to run kind, which we use to create in this bootstrap environment what we call the bootstrap cluster. So this is actually just what I'm doing right now on on my laptop, I just created a client cluster. So now, as an admin of this example deployment of Silva that we are doing today, I can set up a few configuration files that I will use to create this Bootstrap cluster to actually start things in this Bootstrap cluster. And the first thing that we start in the Bootstrap cluster is to install FluxCD and to start creating FluxCD objects that will define the deployment of a few components. I will not list them all, but the key ones in the Bootstrap cluster are the different component that we need for cluster API, which is cluster API itself, the providers, and the dependencies of cluster API, in particular Cert Manager. And what we also define as a Flex resources is the Kubernetes resources based on the cluster API CRDs that define the management cluster itself. So once the definition for the management cluster is put inside the Bootstrap cluster, the cluster API providers will start actually implementing, creating instantiating the management cluster. So depending on what we put in the definition of the management cluster, it will be created either on OpenStack VMs, on bare metal servers, on vSphere, on a local Docker, depending on the flavor that you choose to deploy. And following the creation of the management cluster itself via cluster API, we also follow, it's completely directly orchestrated by Flux resources that are sitting in the Bootstrap cluster. We follow by the installation of FluxCD on the management cluster. We also install other components that are needed early in the beginning, like a CNI, if you're using a flavor of Kubernetes that doesn't has a CNI built-in. So we need to add a Calico in the case of KubeADM and not in the case of RK2, for instance. But we also install all the stack, also based on Flux resources in the management cluster. So all the stack is all the component that you can wish to have in your management cluster. So Silva comes with a collection of components that are ready to be deployed in the management cluster. For instance, again, I will not list them all, but it comes with a Vault or Tri-V for security audits. It comes with a Ciender CSI that you can use with OpenStack as a CSI. Actually, many components, and the point here is not to list them all. And of course, it comes with cluster API itself and the providers that you need to have in the management cluster to create the workload clusters that the users of the CAS will be using. Because of course, the ultimate goal of Silva is to produce a CAS platform. So we need something to create the workload cluster. But once we have a cluster API in the management cluster, we can, and you will see why it's important here, we can actually have the cluster API controllers in the management cluster manage the management cluster itself. This is something that's called the pivot operation in the cluster API terminology. Something that's extremely convenient to allow to have, in our case, a management of the life cycle of the management cluster itself. Because once the management cluster is managing itself, it's able to update itself or upgrade itself without any need for the Bootstrap cluster. So the operation that comes next after starting the installation of a component in the management cluster is to actually do this pivot operation. And once the pivot operation is done, the Bootstrap cluster is not used anymore. You could actually completely destroy it as long as you have taken the time of getting the Kubernetes credentials, the kubeconfig for the management cluster, because of course, to interact with the management cluster, you will need those credentials. So once we have installed all the components in the management cluster, it can start to be used as a CAS platform. So, and this is a part that in Silva today is not completely finished in terms of defining a workflow and the structuring the way the manifests are defined for the workflow clusters and the components deployed into them. But we have the let's say a skeleton in place to show what defining workload cluster can look like. The goal being to allow workload cluster users to define, to put the definitions for their workload cluster in a Git and rely on a GitOps workflow to have those Kubernetes resources defining the cluster be defined on the management cluster. And then as soon as those resources are created, cluster API in the management cluster will actually work on creating or updating the different workload clusters. So now the next thing that we, so maybe there are questions because I don't want to talk too much and prevent interactivity here. So maybe there are questions on this part, which is an explanation that maybe some of you already went through in the past presentation.
Maybe a question on the hosting for the Kubernetes. Is it the same OpenStack or same VMware required, or can it be anywhere? The workload and the management, should it be the same OpenStack, or?
There is no requirement for using the same OpenStack at all. Actually, you could have a management cluster on bare metal servers and workload clusters on OpenStack, or vice versa. Or you could have a management cluster on vSphere and the workload clusters on bare metal, even though it's not something that's targeted for the first release. But there is no design constraint here, and it could perfectly be a different OpenStack. Basically, the only place where you tell which OpenStack is used is in each definition for each cluster. So it's completely flexible.
Actually, Telecom Italia is testing some deployment of the management cluster in a VMware environment, while the workload cluster are deployed in bare metal.
Yeah,
correct.
So the next thing that is maybe interesting to explain is how we structure the way that we define all the different software components that sit in the management cluster. We had a way to solve a few issues. One is the fact that we need to have a proper dependency respected in the order in which the components are deployed, because some components depend on other components being deployed beforehand. For instance, SAP Manager is a component that is a prerequisite for many other components. That's just an example. We needed a way to make sure that we can know in which state a component is it deployed or not. We needed a way to ship the definitions for our components. So sometimes the software component that we use are packaged as plain Kubernetes manifest files. Sometimes they are packaged as Kubernetes customized files. Sometimes we consume components packaged as hand charts. We also need to maintain the values for those components. So what we did for Silva was to actually build an umbrella hand chart that addresses these different issues and allow us to have a single point of entry that determines that acts as a place where we configure the different software components, a place where we can actually add some in a given environment if we want to customize it, even though that's not necessary, and as a point where everything is basically coordinated, and we actually this umbrella chart is actually at the core of the way Silva works today. So let me just share one diagram for this, explain this more graphically. But that's actually the README of the chart.
And just about the animation that Thomas shared, it's also hosted in the Silva Core documentation section.
Yes, indeed. So basically, as you understood, we heavily rely on Flux. So Flux is interested in many regards and allowed us to address some of the issues that I just mentioned. So what we do is that we have this Silva units key chart, and everything is coordinated from there. But it's actually a very specific hand chart. Most of the charts that you see are charts that produce Kubernetes config maps, deployments, stateful sets, daemon sets, this kind of things. Here we have a hand chart that only produces Flux CD object. Actually, more specifically, essentially, it produces customizations and Helm releases, which are the resources used by Flux to consume definitions that are outside of the cluster, typically in a Git repo, with local resources. So we have the central Silva units hand chart that to which we give as inputs the values, the parameters for our deployment, values in the Helm terminology. In the values, those values allow us to enable or disable what we call the units. Units is actually a very basic name that we elected to designate a software component deployed by in the context of Silva. We purposefully avoided the component term, which would have been suitable as well, but we decided to avoid it because it's a term that's already used in the terminology of the Kubernetes customized tool, and we wanted to avoid this confusing collision. So as the inputs of this hand chart, we can configure values to enable or disable units, to provide the settings for our deployment. Some parameters are mandatory. For instance, if we want to deploy on OpenStack, we have mandatory parameters like the credentials. We can also override any parameter that of a given piece of software deployed by Silva. So all of this is consumed by the Helm release, merged with the default values. So that's the typical behavior. That's the behavior with Helm, that the values, the user provided values, are combined with the default values of the chart, and the chart produces customization, Flux customization, and Helm releases. And then once the chart has defined those, it's actually Flux that does all the work of creating the resources defined by those customizations and Helm releases, and following the declaration of dependencies, get the whole sequence running. So we have a few customizations, a few units that act as a special role for coordinating the pivot operation and the coordinating the bootstrap, the pivot, and the management cluster deployment. And all this is happening basically transparently. We didn't write code to act to implement this coordination. It's all based on resource definitions via Flux objects defined by this central umbrella chart. I can maybe go back to the platform, because I actually didn't start the deployment. So we have a single shell script that really doesn't do much. Just installs Flux. We'll actually start it. It actually installs Flux on the Bootstrap cluster, which is usually pretty quick. Then it waits for Flux to be ready, because we actually, of course, need it to be ready before doing anything. And then it will simply do one thing, which is instantiate one release of this umbrella Helm chart, into which we feed the values we want for our deployment. So it actually has a validation step. The Helm chart that we wrote has a JSON schema, which is a built-in feature into Helm that allows to validate the values given as input to the chart. This is something that avoids lots of non-interesting issues that could be due to typos or putting a parameter in the wrong place or with the wrong format. And then once this Silva unit's Helm release is ready, we just, this bootstrap.sh script doesn't do anything else than looking at the deployment happening. It just looks at FluxCD resources and tells us how they are progressing. So this is where the Silva CTL tool comes into play. It's not a tool that I would say interacts with the platforms modifying it. It only looks at what is happening. It just sometimes do a little bit of a nudge, forcing the reconciliation of Flux resources to avoid having to wait for the periodic reconciliation, just to win a few tens of seconds or minutes in a deployment. But it doesn't do anything else than that. So here that we see that the different components are being installed on the platform. We see Cert Manager that has been installed completely. We see CAPI Cluster API that is being installed. We see Cluster API, the Cluster API OpenStack provider, which is a Capo, and the kubeADM provider that is also installed. Well, I won't list them all. And then we see that we have this cluster customization, which is the customization containing the definition for the Bootstrap cluster that is being created. And then we have starting now the Calico definition. The cluster isn't actually created. So it's being created behind the scene. We can actually look at it. RCTL is the open tool of the Cluster API community to have a.
We only have 13 minutes left.
Oh, that quick. So I will let the deployment pursue, and maybe we can jump into questions. Oh no, sorry, yeah, Matthew, you will tell me that I need to explain what I put in the values to customize.
Yes, this is an interesting part for anybody to understand what has to be put to deploy in your context.
Yep, I will jump to that and let the deployment progress. Oops, when I started the bootstrap.sh, I just gave it. Oops, that's a bit messy, but I just gave it the name of the directory containing my parameters, which in my case is called.
Can you go full screen?
In my case, it's called the kubeADM Capo because it's a deployment with the kubeADM bootstrap provider with the Capo infrastructure provider, which is the name of the Cluster API backend for OpenStack. So in this directory, I actually have one key file, one important file, which is the values.yaml file. So this is the file that that is fed into the FluxCD Helm release for the Silva units. It's fed into this Helm release because we use the ability of the Helm release FluxCD object to consume values from a config map. So this value file is mapped into a config map, and then the Helm release object points to this config map. So here well, in the general case, you don't necessarily need many things in the values for a given environment. For instance, for a kubeadm capd environment running locally on your Docker, you can just use an empty values file. You don't have anything well, not an empty. Sorry, I'm doing a bit too fast. You still need to actually tell it to use a capd and define which bootstrap provider is being used. But my point is that it can be very small. In the case of Capo, there are a bit more things that we need to specify, even though what you see here, not everything is in what you see here, not everything is mandatory. So the key part is that we first need to say which providers we're using for Capi. So we need to tell that the infra provider is Capo, that the bootstrap provider is kubeadm. So KBPK is actually the keyword for kubeadm in the cluster API terminology. We also need to tell for deployment what is the name of the glance image, so the OS image to use for the deployment. Specifically for Capo, we also need to give an SSH key name and the OpenStack network ID of the network to use. And you also need to give the deployment an external IP that will be used in OpenStack for external connectivity of the management cluster to the outside. In my case here, I need also to define proxies because I'm behind a corporate proxy. So this deployment is made by reaching out to the internet to find the different resources, and I need to define the proxy. We also have a registry mirror for Docker.io to avoid a rate limiting. So we have a local registry mirror that is configured here. And then this is maybe one of the most interesting parts. I have override for the settings for a few units. So as you remember, the units are the pieces of software or comparable components or generally Kubernetes resource definitions in the context of Silva. So here for a few units, I have overrides. I have one override for the cluster unit, which is the unit that defines the management cluster. Here I did actually a deployment based on a manifest that are maintained internally at Orange for have a few specificities for one OpenStack deployment. And I also introduced customized patches to actually enable some features or disable some features of here, in one case, the OpenStack cluster or addition of NTP servers for kubeadm control plane. It's just an example because typically in the case of NTP, we should be able to support very soon the configuration of NTP servers as a global parameter common to all clusters, not only the management, but also workload clusters. I have one unit defining overriding the default for an example workload cluster, for which we have to define a distinct external IP than the management cluster. I also have one customization for the Trivy operator, and I have been disabling the monitoring component because I was a bit tight on resources on this deployment. I'm also using one definition for a Git repo, which has those manifests that were specific to Orange. But basically, the point.
Sorry.
Yeah.
No, this
yeah,
is really the key point here is that thanks to the Silva Core Helm chart, you will be able to customize any components that are shipped into Silva for adapting to your context, or even adding new components that you want to see into the Silva you are deploying in your enterprise or in your context. So patching, adding, adapting the Silva stack is made easy thanks to this Silva Core project.
Yes, as you say, Mathieu, the point is to have a single point of entry to define the values for a given deployment, and to have this single place allow you to customize all of what you need for any component deployed by Silva. So something that we didn't show here, but that we will be developing in the coming months, is the fact that those values that define the parameters for a given deployment will be naturally handled by a GitOps workflow. It will not be the only way to use Silva. It will be one of the ways, but it will allow to have a given Silva deployment, the configuration of a given Silva deployment to be handled entirely based on GitOps principles.
So we only have 5 minutes left. Just one point. I'm sharing my screen back about the contribution process. So all the developers are discussing on a specific Slack channel that you can join, of course. Don't hesitate to ask questions on it. We can easily answer. We are connected on it all the time, so don't hesitate to ping me or Thomas or any developer to ask questions. You can also fill an issue. Probably most of the issue should land into Silva Core. Oh, sorry, I'm not sharing. So the Slack channel I mentioned, filling an issue is also a good way to discuss any improvement of any Silva components. It's a nice way to discuss the introduction of new features, for instance. And but you must be aware that for participating to the Silva developments, you must sign the CLA. Your company must have signed the CLA for any company developer to be part of Silva developers team. And we are working on the process to better define any request for announcement as it is done in the Kubernetes or in the OpenStack project. We need a place to better understand, discuss, define the testing workflow for new features. So this has to be discussed upstream before the introduction of it into the Silva stack. I let the floor to questions. Anyone want to have some question or want to comment? So you will find also most of what we explained today is part of the Silva Core README and the Silva Core documentation. Don't hesitate to have a look at it. Try to deploy the stack on your own environment. If you need any help, don't hesitate to ping us on the Slack channel or fill an issue. Don't be shy on it. And we are glad to help you on this.
Yep, thank you very much for listening. My apologies for the let's say demo that was a bit. I mean, we talked more about the rest than the demo. The deployment was a bit
successful.
Actually, not. I'm something stuck on one of the OpenStack VMs, so I will just. Yeah, we can still answer any question you have.
Just to, if the deployment is successful, then you can access the Rancher portal. You can access also the Flux portal, the Flux Web UI, and of course you can access the management cluster thanks to the generated kubectl file. So that's it for the first meeting. We are almost running out of time. So just to tell you that this kind of meeting will happen every week. Next week, we will mostly discuss about features and bugs that are discussed in the Silva development project. If you need some explanation about what we presented today, don't hesitate to attend the meeting next week and to ask questions. Let's start this weekly meeting for Silva to be a successful development community.
Thank you.
Thank you very much.
Bye.
Thank you.
Thank you very much.
Thank
Bye.
you for attending.
Bye-bye.
Thank you.
Bye-bye.
Thank you so much.
Thank you. Bye-bye.
Thank you all. Bye bye.
Thank you. Bye.
Thank you. Bye bye.